All right, hello students. Today we're moving on with lesson number 27, one-step equations using multiplication and division. So now we're going to talk about how we solve these basic equations and find the solution using multiplication and division. So let's go over, let's go over example 1. So it says solve 3z, which remember this means multiplication, 3 times z equal 9 using a tape diagram and algebraically. Then check your answers. So let's kind of go step by step, kind of like we did with addition and subtraction. Now let's use multiplication division. It says first, draw two tape diagrams. One that represents each side of the equation. So first, just like before, because this is multiplication, we have the 9 on one side. So we're going to go ahead. Let me enlarge this a little bit more so I can get my tools. There we go. So we have one tape diagram, This equals 9. Because remember, that's one side of the equation. That's this side of the equation. And now this is going to equal, remember, the other side of the equation. You really don't need the equal sign here. I like to put it there to show the equivalency. And remember, this has to equal the same thing, so the lengths should be about the same. Now it says 3z. So now we got to break this up into 3 equal parts and label them all z. So if I kind of break it up here and go, this would be a z, this would be a z, and this would be a z, because this is 3 groups of z, like the left side says. So now it's set, so there you go. There's our tape diagram. We represented the one side, the 9, and then the other side, the 3z. If 9 had been split into 3 groups, like it has here, how much would each group be? So if this is being broken up into 3 equal groups, what would each of these z's be? Well, it would be 3. Why? Because 3 plus 3 plus 3 equals 9, or 3 times 3 equals 9. So z has to be represented by 3. Now I'm going to go ahead and write it as a solution. Remember, this is how we solve or write a solution. Z is equal to 3, because each of these groups would have to be a 3. So now let's go ahead and we're going to demonstrate the value of z using the tape diagram. Well, like we said, from the previous problem, we have this grouping of 9 that's being broken up into 3 equal parts. Well, if that's the case, then each of these would be 3. Well, remember, z in the equation, I'm going to go ahead and write the equation right here. You have it, so you don't need to write this down. But this says 3z equals 9. So z is just one of these parts. It's not all 3 of them. Remember, z is just simply one of these parts. So here is how we demonstrate what z is. Because z is 1, 3 z's give me 9. So if I had 3 z's, that would be 9. So this is how we would demonstrate it using a tape diagram, that z, once again, writing the solution, is equal to 3. All right, so that's using a tape diagram. Now let's go ahead and kind of solve this using algebra or algebraically. So once again, I'm going to write the problem down. Whenever we're solving it algebraically, we always start with the problem itself, or the equation. We find the equal sign and we go ahead and cut it. And what we do to one side, we have to do to the other. Well, since this is multiplication, we get rid of multiplication by division. And remember, this little bar here, this fraction bar here, means division. So we're going to divide both sides by 3. This is called using the inverse operation. Well, this is what's going on. Well, this has 3 divided by 3. Well, remember, 3 divided by 3 is 1. So these will show away. 3 divided by 3 is 1, so we're left with 1z. And that's what we want. We want 1z to be there. We only want one group, so these, as you can see, there's only 1z here. So we want 1z. And of course, then we can do the division over here. 9 divided by 3 is 3. Well, when we're writing this with a variable, we don't need this 1 here, this coefficient of 1. If we look up here at the tape diagram, this is 1z. I know it's 1z because it's there. If it was 0z, there wouldn't be a z there. So this right here, this z by itself, means 1z. So we can actually drop the 1. This is how we write the solution. This is 1z equals 3, or just simply z equals 3. And there's your solution. So this is how we solve it algebraically. If we have multiplication going on, remember this is 3 times z. We use division. We use the fraction bar to show division to cancel this out, and that goes away. And of course, the z just simply comes down. All right, so there you go. That's how we would solve it algebraically. Let's go ahead and look to see what we need to do next. It says, how does this get us the value of z? Well, using algebra, how did we get the value of z? Well, let's kind of talk about what we did. Well, first we wrote out the equation. So first we wrote, out the equation. That's what we did first. We just simply wrote the equation. Then we used the inverse operation, or inverse operation of multiplication. So I'm going to put that up there. Inverse operation of multiplication, which is division. And then with the division, we solve for z. Okay, so then with division, we solved for the value of z. So first thing we did was we wrote out the equation. Then we used the inverse operation of multiplication, which is division, because they're opposites. And with division, we solve for the value of z. So that's what we did. Next, it says, how can we check? Well, how do we check? Well, we check by substituting in 3 for the value of z. Well, we check by substituting, fix that real quick. Substituting the value of z with 3. So now we're going to go ahead and go through the check just like we did using addition and subtraction. We have 3 times z, and this is equal to 9. Well, with our problem, we're going to take the value of z and we're going to substitute it with 3. So now we have 3. Remember, this is multiplication, so we can use the dot. 3 times 3. And of course, I'm just copying down the right side. And I go ahead and I do the operation. Does 3 times 3 equal 9? The answer is yes. This is our check. 3 times 3 is 9, and it checks out. All right, so that's what we did. Now we're kind of getting into the multiplication and division. So that's our first one with multiplication. Let's go ahead and stop the video and we'll talk about one with division. All right, hello students. Now with example 2, we're going to kind of do the same thing we did with the example 1, but now instead of multiplication, we're going to have a division problem. So same basic idea, but now with division. So it says solve y divided by 4 equals 2 using a tape diagram and algebraically. Then check your answers, okay? It says first draw 2 tape diagrams. One represents each side of the equation. All right, so for division, here we go. Now we have division. So for division, we're going to start off with the actual left side. Well, one box here represents y divided by 4. So remember, y divided by 4 can also be written with the division symbol. Well, all of this is y divided by 4 has to equal the other side, or the right side. Well, all this has to equal 2. So this little box would be 2. So here's a tape diagram representing both sides of the equation. Y divided by 4, or this box of y. Moving on to the next one, it says, if the first tape diagram shows that y divided by 4, so this is the size of y divided by 4, how can we draw the tape diagram to represent y? Well, if y divided by x, y has to be 4 of these because this is broken up into 4 equal parts. So because this is divided by 4, it has to be 4 boxes. So the tape diagram represents y should be 4 of the y divided by 4s. So let's go ahead and type that in there. All right. So it says, the tape diagram represent y should be 4 sections of y divided by 4. All right, so since this is this is y divided by 4, we need 4 of these to represent all of y. So let's go ahead and draw that tape diagram out. All right, so the first top part, now I'm going to make this nice and long, is represented by y. And now 4 of these boxes should represent the whole thing. All right, so what I'm going to do, I'm going to make it equal to it and draw one equal to it. And now I'm going to break this up into 4 equal parts. So if I cut it in half once and then cut those 2 halves into halves, that gives me 4 parts. Each of these are simply y divided by 4. Now I know it's not perfectly the size of the other one, but this is our visual representation. Because y is being divided by 4, I need 4 of these boxes to actually equal the y. So there we go. So 4 of these y divided by 4 is actually equals the y itself because y is being divided by 4. All right, so there's your. Sorry, going back to this. If this was y divided by 5, then there would be 5 boxes down here. If it was 6, there'd be 6 boxes down here. And of course, as the division number changes, the number of boxes would actually change. All right, so let's go and continue on. The next section says, what value does each y divided by 4 section actually represent? And how do you know? Well, based on our first tape diagram, each y divided by 4 section here represents 2. And that's based on our first tape diagram. So it says here, what value does y divided by 4 section represent? It represents 2. And now how do we know that? We know that from our first tape diagram. So let's go ahead and just type that in. Okay, so how do we know? We know, from the first tape diagram. Okay, so we just simply know that from the first diagram given, or actually the equation as well. Okay, so how can we use the tape diagram to show the value of y? Well, if we take the same tape diagram, so we have this value of y, remember, and it's broken up into 4 equal pieces. So I cut in half, then cut in half twice. If each of these y divided by 4s are represented by 2, well, then this would have to equal 2 in each of these boxes, because I'm using this conversion or this equation. Y divided by 4 equals 2. So here's a bunch of y divided by 4s. All of these have to equal 2, so I just plug in 2 to each of them. Okay, so now it says, so what is the value? So now we can demonstrate what the value is. Well, if I add up all of these 2's, I go 2 plus 2 plus 2 plus 2. That, of course, gives me 8. I'm not sure why it's not coming. Maybe it'll pop up here pretty soon. But once again, all these y divided by 4s equal 8. All of these y divided by 4s equal 2. So if I add them up, it gives us a value of 8. Okay, I'm not sure why it's not coming up. Hopefully it should pop up here pretty soon. You know what? Let's go ahead and grab our tape here, our box here. So all of these would have to equal 8. I'm just going to go ahead and type it in since it's not popping up. But how do I figure this out? Because I added up 2 plus 2 plus 2, and of course that equals 8. So I added up all of these boxes, and of course it comes out to 8. Sorry, I drew it in there, but for some reason it's not popping up. All right, so let's go ahead and go down to the next one. How can we demonstrate this algebraically? All right, let's try this again. Let's try to get out another pen. So if we have y divided by 4 equals 2, well, we have division going on right here, just like the other one. If we have division, the opposite of division is multiplication. So if we multiply both sides, oh, sorry, I forgot to cut it. First, we should cut it. If I multiply both sides by what's being divided by 4, or sorry, what y is being divided by, then it should give us our answer. Well, this would cancel out just like with the division and multiplication. The y comes down, and now I did the multiplication. 2 times 4 is 8. And of course, that's the answer we got from the previous problem. Okay, so we're using the inverse operation again to simply solve. And of course, that's what we got when we used the tape diagram. So here's algebraically, here's using a tape diagram. All right, so last part here, very similar to what we did. How does this help us find the value of y? Well, this helps us because we use multiplication, which is the inverse of division. This helps us because we used the inverse operation of division, which is multiplication, to solve, oops, I did it again, or, sorry, trying to go. There goes value of y. All right, so of course, using the inverse operation gives us the value. Okay, now it says, of course, how do we check? We check by substituting. So let's just go through our substitution real quick. Y divided by 4 equals 2. And remember, we said that we think y is equal to 8. So if we went 8 divided by 4 equals 2, let's go ahead and do the division. 8 divided by 4 is 2. And so therefore, it checks out. All right, so that's that one. Sorry for the little technical difficulty, but hopefully we have that cleared up. All right, this time you're going to get these to try on your own. You're going to try exercise 1, 2, and 3 on your own. This one says, of course, one says use a tape diagram. This says use algebraically, and the last one you can solve however you want to, either using algebraically or using a tape diagram. So go ahead and pause the video and give these a try. All right, welcome back. Hopefully you gave them a try on your own. So remember, on the tape diagram, first we want to write the number that's all by itself because this is a multiplication problem. So this would be 21. And then this is going to equal, and of course, the other tape diagram has to equal the same length. And of course, it's 3m. So it needs to be broken up into 3 equal parts of m. All right, and so the question is, what would m have to be? Well, what would one of these boxes of m actually have to equal? Well, of course, we're breaking this up into 3 equal parts, so that would be a 7. So m would equal 7. So your tape diagram should look something like this. If you have 7 on all of them, that's perfectly fine. But of course, this is what you should have came up with. All right, the next one, hopefully you have this done algebraically, which means I have division going on right now. So I cut this on both sides, and of course this is division, so I want to multiply. we want to use the dot because we're using a variable. So I'm going to use the dot for multiplication. So dot 5, so we're going to multiply by 5. And this side I'm also going to multiply by 5. So I do this because these 5s cancel out. That's 5 divided by 5 gives me 1n. And now I do the multiplication. 5 times 5 is 25. Carry the 2. 5 times 1 is 5, plus 2 is 7. So 75 equals n, but really we want to put the n first. N equals 75. All right, so there's your solution for that one. And now on part 3, or problem number 3, you should have solved it however you want to, either using the algebra or using a tape diagram. So I'm just going to go ahead and give you the answer. Hopefully you came up with P is equal to 9 because 9 times 4 is P. So on this, you should have some kind of work here. So when I come by and look at it, I should see some work being done either using the algebra like we used in problem 2 or using a tape diagram similar to what we used in problem 1. All right, go ahead and stop the video. Go ahead and move on to your lesson or assignment for today.